How do we know what we know about turfgrass science? Welcome to Turfgrass Epistemology. Good evening, everybody. Welcome to Turfgrass Epistemology. My name is Travis Shaddix. Thanks for being here tonight. We're going to continue in this episode to be going over water. As I do occasionally, I come across articles in availability, and when I can, I try to have the author on to talk about their paper. It's certainly they know it better than I do. And tonight I've done that. I'm able to get on Dr. Dan Sandor from Virginia Tech. Good evening, Dan.
Hey, Travis. How are you doing tonight?
I'm doing good. Thank you for coming on tonight. For those who, don't know about the behind the scenes stuff, it takes me like 25 minutes to get this thing running. So I appreciate your patience while I was getting everything going before the show started. But we're on tonight. I'm pretty sure I fixed the audio problem, so it should sound better than the last guest I had on. I feel bad that I couldn't figure out the audio prior to that. But Dan, I've sort of crossed paths with you over the years at various meetings. We haven't really ever sat down and had lunch or dinner or anything, but you've been on my radar for a while when you were at Arkansas with the great faculty and staff over at Arkansas. So I'm sort of familiar with you, but I wonder if you might just give us a, elevator speech on who you are, where you came from, and what you're doing now.
Yeah, absolutely. Thank you, Travis. And likewise, I know I followed a lot of your stuff, and I think in our earlier conversation, I follow you on Twitter and listened to a few episodes of the podcast and this year. So I appreciate you having me on tonight to share a little bit about our research from my PhD work. As Travis mentioned, I did my PhD at the University of Arkansas there in Fayetteville from 2013 to 2018. And one of the projects of my PhD we'll talk about tonight with irrigation during establishment. Got to work under Doug Karcher and Mike Richardson there to really get turf faculty. I think Travis has had Dr. Richardson on recently on the podcast, so hopefully you all learned a lot from him. And just most of that research was all focused on water conservation. If you guys remember 10 years ago or so, and even probably right now as well, but, water conservation has really become important and at the top of a lot of concerns in golf courses, sports fields, lawns, and landscapes. And it's, something I was kind of curious about and wanted to figure out, looking at some different practices and different technologies and things. So it was a good 5 years. I think the best thing out of being at Arkansas, though, aside from the research and the advising and mentorship and expertise, was the grad students that I worked with out there that have now all gone on to work in industry or also be my counterparts and faculty at other land grant institutions. So we're a really close-knit group, and I would encourage all of you, if you're thinking about going to grad school, if you're thinking about even just going back to school, whether it's grad school or not, or even a certificate program, to find some teammates, find some people to do it with you. You guys can encourage each other, work together, study together, just whatever it is. It seems like Travis has a pretty loyal listener fan base, or whatever you want to call it, a cohort of sorts. And I don't know, Travis, if you have like a discussion board or something just for the members, but I would imagine there's a lot of learning that goes on, on those discussion boards, like sharing of ideas, exchanging of ideas and information. So I think that's one of the awesome things about the turf industry is that, like Travis said, like even though I never have worked in the same place with Travis, I've only maybe seen him for like a 2-minute hi and bye at a meeting or something. If I have a fertility question or a soil testing question, I know Travis is there at the top of the list in terms of like, well, I may not know this at the moment, but I know an expert to reach out to. And that's what I hope you guys are going to get out of these series of podcasts and webinars and things that Travis is hosting. So I know that was supposed to be an elevator speech, but just real short before that is I was at WKU, Western Kentucky University in Bowling Green, Kentucky for my undergrad and my master's. All of that was in turf. I went turf all the way, which is probably not ideal. So not well-rounded, but it was a good experience in all those locations. After graduating at Arkansas, I was at University of Minnesota for about a year and a half. We'll talk a little bit about what I did up there in our discussion tonight. It has some relevance to the paper we were discussing, but it was a great situation. Dr. Eric Watkins, Dr. Brian Horgan, two really solid guys that had run the turf program up there for many years, provided me the opportunity to be a postdoc out there. And then in Thanksgiving of 2019, I moved out here and began as a faculty member here at the Turfgrass Science team at Virginia Tech, Virginia
You,
Tech in
you said
Blacksburg. So,
you said 2019?
yep,
Okay.
Thanksgiving 2019. So,
Well, oh my
um,
goodness, you've been there for 6 years, five and a half
yeah,
years. Oh my
well, I mean,
gosh.
right after I moved here, COVID happened, so everything
Oh,
was kind of a blur. I was here for about 3 months, and then the
hmm.
world changed for all of us. So it
Yeah.
has been surreal trying to just started like when that started, just trying to figure out what do I do? Where are my
Yeah.
students at? How do I help them? Everything you had planned to do as teaching and research and things, where all those things kind of got thrown out the window and everything moved
Hmm.
to virtual and
Yeah.
things. And so, but no, it's good. I mean, the thing that has always been helpful, whether it's Minnesota, whether it's Kentucky, whether it's Arkansas, whether it's here, is the great team that I work with. And I think that's really important. Whether you're in the turf industry or if you're not in the turf industry, but you're just a fan of the podcast and you work a different job, um, the team that you work with is going to be your best support in terms of getting stuff done, but also helping you grow
Yeah.
and learn more things. So
Sure. Yeah. It's a team. It's a group effort. It's not only who you know, but who knows you. And, you know, if I suppose if I had to do it over again, I focused a lot on the research and a lot of the work as I was going through grad school and I was doing other things. And looking back on it, I probably should have spent more time developing relationships than my nose in a book all the time. But because those relationships could stay with you for a long time, for sure. So that's just as valuable, if not more valuable in some cases, than the education you gain. So, like there's a saying, my neighbor across the street is a professor at Morehead State. And he has a saying he uses, like, I don't know the answer to that, but I know who knows the answer to that. And that's invaluable if you have that network of friends and professionals. Because, like I said, no one knows everything about everything. But your network of friends and network of colleagues can definitely, answer more questions than just one person. But I'm interested in, you went to Western Kentucky. You went straight from Western Kentucky to Arkansas.
mhm.
When you showed up in Arkansas, was there already a project there for you, or did you develop this? How did that come about?
So there was a few projects that Dr. Karcher had kind of thinking was thinking about,
Yeah.
and I remember when I visited. I can't remember when it was, but it would have been earlier in the spring. There was actually potentially a study for earthworm casts on tee boxes.
Hmm.
And if you've ever Googled earthworm casts and golf, the last probably half decade or so, probably more than likely than not, my colleague, Dr. Paige Boyle, his name comes up, and she got to do that as part of her master's. So I didn't have to deal with that
Okay.
there. So I remember when I got there, I was like, it's like, so what project am I doing? Am I doing the worm cast thing?
Okay.
And so that ended up not happening. To be honest, Travis, I'm not 100% sure how it started, other than I remember having a conversation with Dr. Karcher. This would have
Yeah.
been August 2013,
Hmm.
and we were just trying to think of ideas. And one of the challenges is, if we remember back 12 years ago, almost 12 years ago now, is there was a significant drought going
Yeah.
on across the country, especially out in the Southwest um, area in Southern California. But I at that time in the industry, um, a lot of the irrigation companies were getting big into technologies, and
Hmm.
so kind of the meat of my dissertation, the big project, was looking at irrigation sensors.
Okay.
And so I was kind of tasked with, doing some developing a project and developing some work looking at irrigation technology and irrigation sensors. Obviously down at Florida where you were at before, and I don't know how closely that you would have worked with these guys, but because I know they don't really work super close with Dr. Unruh um, uh, and Dr. Cruz down there, and some of the other guys that have moved there now recently, but
Mm-hmm.
the biological systems engineering for the ASABE guys, they did all that irrigation sensor turf stuff, and they were really just looking at it from the water conservation stuff. They weren't really getting deep in the weeds in terms of turf ecology or turf quality type of things.
Mm.
They had done a lot of work on irrigation sensors, irrigation stuff down there in Florida. Florida has a great, extension program. We'll talk a little bit about that later on tonight, but about some of the things that I think we can learn from those programs. But
Yeah.
I had kind of contacted them, was seeing what they were doing. Obviously, it's way different climate, way different soil textures in Florida compared to Arkansas. Some of the sensors and technologies that they were using was a little bit more expensive than what a traditional homeowner or a homeowner with a traditional irrigation system or sprinkler system. It's kind of the term that we use more on the residential side. Things that were some of the new technology that the manufacturers like Toro, Hunter, Rainbird, which are probably the three big players in the irrigation market. We were looking at some of the tools that they had came out with. So that was
Mm.
that, and then it kind of like branched off from there in terms of the rest of the projects with the dissertation. We did some field work looking at some irrigation programming and based on ET or evapotranspiration. One of the challenges with that was that we also had a lot of rain
Mm.
that really limited any drought stress from occurring in one of the field trials. So
Mm-hmm.
did a couple greenhouse stuff looking at some irrigation frequencies and things. Uh, but then the other study is the one we're going to talk about tonight, where honestly, this is maybe just one of those eureka moments that people have in their life sometimes. But I just remember reading through the literature and reading through a lot of things like extension bulletins, fact sheets, even just small research reports, things that you would see in local municipality, programming, education, conservation efforts, and the study that we'll talk about tonight. This was kind of just a thing that came to my head was, hey, you know what? There's really no specificity to irrigation instructions during establishment, and a lot of this is pretty general and vague. And we'll get into it here in a few minutes, but so that project just kind of came out of the blue.
Okay.
I I wouldn't say it's my most extensive project, but it's definitely a Dan Sandor original. um,
Okay.
in the sense of like I was just like, you know what, like we're just gonna see like what happens, and obviously
Yeah.
there was a lot of people. Like it's not. I say that maybe tongue in cheek, and there's obviously been a lot of research looking at irrigation practices, and I know
Sure.
Mateo and Marco and a lot of the New
Mm.
Mexico State guys and the guys in Southern California have done some equivalent work
Oh
as
yeah.
we did, but uh, it was just kind of one of those things where I had some seed and I had irrigation. We're like, ah, let's just go for it. We got a
Yeah.
month,
Yeah.
so
Yeah. I get that question fairly frequently. How what sort of irrigation regime should you use during establishment? And being from Florida, a lot of my work is done on sprigs or sod. We don't really do a lot of seeding down there, or at least not anymore. In the late '90s, there was some overseeding here and there, um, but when I moved to Kentucky, there's, with the exception of some bluegrasses, there's very little sod. It's mostly tall fescue seed or blue Kentucky bluegrass seed or ryegrass seed or whatever. And I have my own little recipe I use. But the question that I get a lot is like, how frequently should I irrigate? And just again, tongue in cheek, like you mentioned, I generally would tell people, whatever you're irrigating, it's probably twice as much as you need. Okay, I'm just letting you know, because if you do the math on reference ET, and then you actually go to your irrigation system and try to apply that amount of water, you realize like, whoa, that is a fraction of what I'm applying. And so I'm glad, that's the reason I wanted you to come on tonight, is that's what this paper is about, is irrigation requirements during seeding with tall fescue and Bermuda. So we're dealing with warm season and cool season. Of course, Arkansas is in the transition zone. So I think that's a good segue into the actual article. And Dan and yourself and Tyler Carr, where's Tyler? And I ran into him at Sportsfield Complex somewhere. Where was it? Is he?
he may like to be there some days, but he's actually just north of you up I-71 there. He's the extension specialist
Oh, in Ohio.
for the state of Ohio.
Ohio
Yes.
State. Yeah, that's where I mean
Ohio
he was
State.
he was at SFMA a couple of years ago. Anyway, and then of course Dr. Karch and Dr. Richardson. Dr. Karch is in Ohio now, and
Doug's his
Richardson's.
boss again.
Yeah, I guess it is. Yeah, I just recognize. I realized that, but I think he'd be a good boss to work with. That's for sure. So, well,
Absolutely.
let's get started in the article. And for those people who are in, whether you're in cool season land or warm season land, Bermudas or tall fescue, seeding it, this paper will kind of give us some information on how to actually irrigate it during that time period. So, do you want to kind of just go through the introduction a little bit of like, you know you and I know the problems, but just for the audience in terms of why are we doing this work? Why is it important that we know how to irrigate during seeding of tall fescue in Bermuda?
Yeah. So I think going back to one of the questions we talked about earlier was, what were some of these projects? If you think back to what was going on in the country at the time, especially in more of the drought-stricken areas. And I will say I'm not completely aware of how irrigation mandates and things have been for the last 20 years or so. I can only speak to maybe about the last 10 years, maybe.
Okay.
But when I was there in Arkansas, you just really started to see a lot of or hear a lot of things about irrigation restrictions and how you can only water during certain days of the week. If your house ended in an even number, watering on even days and odd days for odd numbers and
Yeah.
those things, or
Sure.
other limitations. Maybe time of day was something, and along with day of week. So um, it's just kind of one of those challenges that we were trying to kind of navigate around. And of course, people are pointing the finger at turf, like that's why we have these restrictions, or that's why we're saving water because you all are over irrigating turf, and turf is bad for the environment, and all these things that I think you had Ross on here, and I know Ross probably did a good job of kind of showing otherwise that when we point the finger at turf, we're completely ignoring the holistic, benefits of the environmental and the functional and all the other benefits that turf grasses provide. So it's kind of one of those battles I kind of felt as a PhD student. It was like, well, how can I help lessen the impact or the scrutiny, the impact from the scrutiny of turf, and some of this research. And so I kind of looked more at the mandates and looked more at the restrictions. And one thing that I started to notice was that there weren't really any restrictions during establishment. And even so today, where you may still have irrigation restrictions in various parts of the country, especially during this time of the year and during this heat wave that probably many of us are in right now. Um, a lot of times those restrictions don't apply to the first 4 to 6 weeks if you're seeding. I haven't really been aware of any that talk about sods or sprigs. Obviously, more so on the homeowner market, most people are probably seeding or in some cases sodding. And you mentioned that earlier, Travis. I think somebody, whether it's myself or if any grad students are listening and want to take an idea and run with it, I think doing a similar research project, looking at irrigation practices for sod and sprig establishment would be great to have that information. But backtracking to these mandates, I was like, well, let's see what happens. Let's see if we can identify how much water will result in a successful establishment. And one of the things that, as we talked about earlier, is that we know and we see it as you drive to work, as you come home from work, maybe. I mean, hopefully it hasn't been running the whole 8 or 10 hours you've been gone at the office, but irrigation systems are just running a lot. And as you mentioned earlier, people may not even be aware that you really only have to run it for maybe 12 minutes or 20 minutes instead of an hour or 45 minutes or an hour and a half, or to put out your irrigation to provide adequate water during establishment. So because one of the challenges that I think a lot of homeowners are faced with, and a lot of even professionals that are seeding, and especially on maybe more lower budget or lower level, or even less labor, have a smaller crew. If they're seeding areas, maybe it's not the game field, but it's other areas, utility areas or other areas, or other parts of the golf course. Well, how much water should I apply?
Yeah.
We're obviously not providing recommendations in terms of minutes, and we always, as scientists and as researchers, we're like, we recommend irrigation in terms of volume, in terms of usually in United States, in terms of inches, and elsewhere in the world in terms of maybe millimeters per day or inches per day. But you don't see those recommendations. You don't see a volumetric recommendation um, during the establishment period. And I may be mistaken. I'll stand up and be the first one to say it. But in a lot of extension bulletins, I don't know how many I reviewed, but I kind of went through each state and reviewed the extension bulletins to see were there any specific volumetric recommendations, or anything really. And
Yeah.
a lot of the language in there was very vague, very ambiguous. There were some that did provide a recommended estimate of 1 inch of water or 2 inches of water, which is a lot of water for
It
a
is.
bare soil. If you're just specifically starting from scratch and just have seed there. So
Yeah.
but you also have like language that says, and I think it's at the bottom of the paper on page one,
Mm.
that talks about maintain moist but not excessively wet soil. That was a direct quote taken from one of
Oh, yeah.
the extension bulletins. Like, well, what does that mean? Maintain moist but not excessively wet um,
Yeah.
soil. Even like right before that, like light irrigation
Yeah.
applications.
Yeah.
Applications aimed to wet soil moisture at the depth of 1 to 2 inches. I don't know. There's a lot of just similar things that, in terms of
Yeah.
scheduling terminology, that was just very ambiguous, very vague. And I guess for most of us, if we've ever done it before, even if we've seen it done, we kind of like, okay. But and that may be okay if we have kind of a feel
Mm.
for it, or if
Sure. Yeah.
you're there, even if you haven't done it before, but you're there doing it, and then you can kind of realize, oh, it's starting to puddle up. I need to scale back on this or things. But
Yeah.
for maybe the average homeowner, or somebody who's just trying to get something established, maybe they're doing it for erosion control. They need to get the ryegrass established right away.
Hmm.
But we don't want to put out so much water that it washes away or stand or seedlings. So
Sure. Yeah.
and we've seen that a lot of um, things don't change once you maybe already start doing them. And I say that, maybe to say this better, is that once a especially on the homeowner side, but I've even seen professionals situations or commercial situations, commercial facilities be guilty of this too. Is once you set an irrigation program, the likelihood of them changing it is very small.
Sure.
um,
Yeah.
to begin with. There's a number of papers. I think Dale Bremer and his crew out at Kansas State in the early 2010s, they published 3 papers in 2012, 2013, and 2015, all looking at lawn watering behaviors and knowledge of homeowners. And basically, what they saw was that people aren't aware. People don't know how much they water their turf needs. They don't know how to, run their irrigation system, or they don't know how much
Hmm.
water is being put out. They know how to turn it on, but they don't know how much is coming out. So you can imagine, with just the lack of knowledge
Hmm.
from the consumer perspective, plus the lack of specificity in our own land grant extension bulletins and resources, well, that's really not helping. Going back to what we started with, that's really not helping this water conservation challenge.
Yeah.
And so we had been using ET quite a bit. I know your audience knows this, but ET, evapotranspiration. So we've been using it already quite a bit in some of the field studies. We were like, well, maybe we can just use ET as a benchmark for irrigation. We can replace, and in our case, we looked at 100% ET.
Hmm.
So we're going to just replace exactly what was predicted to be lost by a mature stand of turf grass,
Yeah.
um, in that situation. So, and one of those things, I know we're scrolling through the paper here.
Uh-huh.
One of the things that I think I do want to point out, I think on the top of the second page, that first paragraph there, there's a lot of negative impacts, not just from a water usage standpoint,
Mm-hmm.
And the negative scrutiny, the negative image that shows out in the community as you're driving, again, driving to work, driving somewhere in the community, and somebody's sprinkler system's running, and you got water runoff. But it also leads to just a poor stand establishment. Even in
Yeah.
mature turf, increased diseases. I think I've listened to a few episodes on here, and I think you've said it too, Travis. Is that we have a lot of examples of how overwatering or too much water can maybe exacerbate turf problems much more than underwatering and letting the turf go a little bit, experience a little bit of drought stress and things. So same
Mhm.
thing still applies. Same principle still applies with newly established stand or starting from seed. Is like, oh, you're just washing away the soil at that point.
Yeah, and it goes manyfold too, Dan. I mean, the sort of easy to understand concern is that if you're just going to seed it on top of the soil, which a lot of people here do, that seed can just go right off. If it rains a little bit, it's already soaked. The soil's already soaked. The seed can just float right off. And you'll see, as we all have probably seen, unfortunately, all the seeds sort of collect in the lower areas of the lawn or wherever you're seeded. If you didn't knife it in or you didn't slit seed it in or whatever the case is, then that seed can wash off if you don't control the water. That's one issue. But I guess a less thought of issue, and probably, in my opinion, more impactful because I'm a nutrient person, is that you are generally applying nutrients, maybe not the day of seeding, hopefully not the day of seeding, but as it gets grown in a little bit, you apply nutrients. Well, nutrients don't move in air, okay, unless they volatilize, but they move off site because of water. So the excessive amount of water can be so deleterious in many, many levels, especially during seeding or during sprigging as well. When we don't have roots in the soil, there is nothing there to take up the nutrients or to take up the water that we're applying. So it's just, and this is just my limited knowledge of the water literature as well as my experience. It's just this. There's just many times more problems with too much water than there is with not enough water. Not enough water usually can be alleviated very quickly. You go out there, you apply it, you first, hopefully you catch it early, you see it, and you just apply a little bit of water and it resolves it. Too much water, it might take a day or two to kind of get all that stuff, settled out and get the air back in the soil and start the plant kicked up again. So it's just one of those situations where I think the average person, is meaning well. They think they're doing what is necessary to keep their plant alive, but in reality, it may be harming the situation far more than helping. So, it's the old thing where I don't think we have a turf problem. I think we have a people problem or an education problem. That's one reason this channel exists, because I believe I wasn't educating people in an effective way. So, it's not the turf so much as it is education on my end and just people in general, not understanding the system as well as they should, but it's all good. Well, on the paper, the hypothesis, first of all, let me just state this to you personally. It is, you might not be surprised, but the average person, the average scientist might be surprised at how many papers are written without the following sentence in it. The hypothesis tested in this study was da-da-da-da-da-da. That's pretty rare, Dan. I'm telling you. That's what should exist in every paper. But generally, we sort of like throw it all together in the objective statement rather than having a clearly stated hypothesis. So thank you for doing that. And then below that, you say a second hypothesis was da-da-da. And then it says the objectives of the following studies were to evaluate the impacts of irrigation volume and genetic drought resistance on establishment rate of seeded cultivars of Bermuda and tall fescue. So this objective is not a hypothesis. You state the hypothesis. Thank you. And then you state the objectives. It's fine. I'm always amazed, like how many scientists, including myself early on when I was writing, I wouldn't write the hypothesis in a way that was, able to be critiqued, I should say. So anyway, that's the hypothesis and the objectives of your paper. And why don't you tell us a little bit about where you did it, a little bit about the setup. You have some photographs in here. This was by the way, this paper is public access, it's open access, and it's in Crop Forge and Turfgrass Management, so anybody can go download it right now. But in the meantime, while we're walking through this, why don't you kind of fill us in on where you did it and a little bit of the setup, and then we'll walk through it with the photos if you want to.
Yeah, absolutely. Yeah, and if you go and look for that article, we actually landed the cover image. So there's a image of me on the cover of that issue, and
really,
Dr. Carr is pretty proud of himself because Yeah, he took an award-winning, or not an award-winning, but a cover photo worthy picture.
Nice.
So
Well, good
no,
job.
but I appreciate that the kind words about the hypotheses. Um, yeah. So and going back to what you said, Travis, too. Yeah, it's an education problem, but the challenge was that we have a lot of ambiguity. We have a lack of specificity in
Mm-hmm.
the education that's out there and the extension bulletins and the resources out there about irrigation practices during like specific irrigation volumes during establishment. So we looked at using ET. We also with both of these species with tall fescue, with bermudagrass. If you've ever probably if you've been listening to Travis over the past few weeks, and the podcast and the episodes here, there's decades upon decades of drought research out there, and we know there's some within each species or across species, but even within species, there's I guess you would say inter and intra specific differences in drought resistance across the many common turf species we use. And so that was one of the things we looked at too. Was we looked at a known cultivar Bermuda grass with known drought resistance and a cultivar of tall fescue with known drought resistance in terms of they were qualified and highly, strictly evaluated, stringently evaluated under some rainout shelter studies and
Mm-hmm.
across different locations. So that was kind of the only other factor in addition to ET was, is there a difference if you have if you have a cultivar that's genetically drought resistant at maturity, does that mean anything during establishment? So getting into the research, all of this was done at the University of Arkansas, there in Fayetteville, Arkansas. I love Fayetteville. I go back every chance I get. I'm going back for a couple weeks here and um, later in July. So silt loam soil, which is it may not mean anything to you, but Travis mentioned this earlier. I think it's really important. I hope you will think it's really important, not just for today, but as you listen to all the guests that Travis has, and I know he's mentioned it before, is that water behaves very differently, nutrients behave very differently, turf overall behaves very differently in the relationship or in the kind of dynamic range of the soil plant atmosphere continuum. And that soil texture is really important because we had a silt loam soil that we conducted this on, which obviously is going to hold um, a good amount of water compared to sandy soils, which we certainly have that in parts of Arkansas. I live in Virginia now. We have a wide range of soils across the Commonwealth that not every I can't even think of the phrase, but not everything is going to fit for everyone
Mm-hmm.
in each situation. And I think Travis said the word earlier that one of the kind of the silver bullet words or the kind of the key words there is site specific. So, and I think as a researcher, I try to indicate that in most of the research I publish is that yeah, this is what we saw, this is what we did here in Fayetteville, Arkansas, or here in Blacksburg, Virginia. But that doesn't necessarily mean that if you're in where Travis used to be in Gainesville, Florida, or if you're, in New Mexico State or wherever you're at, Denver, Colorado, that doesn't mean it will maybe work for you based upon the soil factors, the adaptive factors there,
Sure.
or even the environmental conditions. So,
Yeah, that's
but
why
we did
INTEP has
also,
so many different locations. I mean, INTEP, people don't know INTEP has dozens of locations when they run these studies. And people get on INTEP and they can look at all the data. And occasionally there might be a cultivar that tends to float towards the top of all locations, but not always. That's the reason I tell people with INTEP or A-list, whatever, you can, find the location that was closest to you. And you can at least use that as a little bit of a guidance as to what cultivars might be more suitable to your location than, say, Seattle or, say, Fort Lauderdale or whatever the case might be. But yeah, you're absolutely right. I mean, just because we show it in Arkansas doesn't mean it's going to work in Mississippi. So anyway, but you talked about different cultivars and different Bermuda grasses and so forth. And it says here Sahara 2 was utilized in this study as a standard Bermuda grass check. Is that the case? And then the tall fescue, where am I seeing the tall fescue at? Did I miss
it's at the
it?
bottom of the other column. I think, yeah, whoever the editor or the publisher, they moved some of the information around, like the way they laid out the columns and
Missed it.
things. I think it's
I can't find it. Some people are really interested in this. I don't even remember the cultivar names, to be honest. But some people are very, very interested in which cultivar was used.
It's in the top
Well,
of
anyway,
the. If you go back to the with a picture of that thing, so
no, this here.
sorry,
Yeah.
it's in that kind of third line. It's right there at the bottom of the screen. The tall on the left column there, the bottom line on the left columm.
Oh, the tall fescue studies were conducted. Oh, here you go. Tall fescue cultivars, Pin RK4 and Rebel Exeta.
We always said Exeta, but I don't know what it is.
I don't know
I've never
either.
heard anybody else say it out loud.
I've never heard of Exeta. I've never heard of that. So, okay, well, those are the cultivars you use. So basically, if I understand the situation correctly, Dan, you have a bermudagrass cultivar, you have or you have bermudagrass and you have tall fescue. You're doing it under this rainout shelter. And you've seeded these plots and you're applying, what are the irrigation treatments? The irrigation treatments are based upon reference ET, but you had a set level of irrigation, the ET levels you went by. What were those?
Yep. And I should clarify for the group if they haven't seen it already. These weren't done at the same time. We did tall fescue. We just had a kind of a light bulb moment per se, as we talked about earlier. It was getting near the end of the season and I was like, well, let's just do this study real quick. And so we did the tall fescue in the fall of 2016. And then did it again in the fall of 2017. In between that, we did the Bermuda grass because there are still a lot of people that, or I don't know about a lot, but there is a number of people that still establish Bermuda grass from seed as opposed to sprigs or sod, especially maybe more so on the residential and some of the commercial markets.
Yeah.
So we did those in the summer of 2017. And then it was repeated again by my colleague, Dr. Carr. I'd already moved to Minnesota at the time, and he was kind enough to repeat the Bermuda grass run in 2019 summer. So, so just to clarify for the group, we weren't trying to do this all at the same time or anything.
Yeah,
we're trying to do it in the favorable windows. And these were, I think, Travis mentioned A-list a minute ago. There's another group if the audience isn't familiar with called the TWCA or the Turfgrass Water Conservation Alliance. And they're very similar to NTEP, very similar to A-List, except for they only focus on water, whereas NTEP and A-List are focused on a whole host of different inputs or variables. And so TWCA, if you've ever seen any of those research trials, a lot of them happen under the structure that Travis mentioned, the rainout shelter, which literally is what it sounds like. It allows us to conduct field research with pretty much all the same environmental conditions as something under the open air, except for we have a plastic covering over it that we took a couple of different PAR meters out there, and it's letting through about 97% PAR light. So very minimal, if any, obstruction in photosynthetic active radiation or PAR light. So we're really only limiting the rainfall, and everything else is the same environmental conditions and things. So
and then you applied. Yeah, I'm sorry. Go ahead. That's where I was going. Right here, I found the irrigation treatments right here. 50. Go ahead. I'm sorry.
Yeah. So we were like, okay, 100% ET, and that's going to be our starting line. And then we just based upon space and how much time I wanted to put in the project. It's like, well, let's just look at these other three levels of this treatment, of the irrigation treatment. So we looked at 125 to kind of see like, all right, this is more than obviously 100. So I don't know if that necessarily meant saturation or overdoing it, but we looked at, okay, if you did more than 125% AT, what effect, if any, would that have? Would it maybe have a negative effect? And then we actually lowered it to 75 and 50% ET. Part of the reason for doing that is one, water conservation. How little can we get away with applying and still have successful establishment? But two is that we have seen, again, from the decades of field research, that turf grasses at maturity, once they're established, they don't need 100% ET. Not all of them, but many of the turf grass species out there, including many of the ones that like Bermuda grass and tall fescues. In fact, many of the improved cultivars, drought-resistant cultivars, they maybe can get away with even 50% ET twice a week, 3 times a week, whatever it is. You don't need to replace 100% ET every time. So we just want to look at that wide range ranging from 50 all the way up to 125% ET replacement.
Yeah, and here you are. I think this photo is of you timing it and spraying this particular plot or subplot or whatever that,
Yep. So what we did there was we knew our area of each plot. So that was a whole plot there. And if you kind of imagine, that was kind of a spray shield there that we made, that box, because you can kind of see up in the corner of the picture, the next plot was close by. So we didn't want to have any drift or water from whatever that treatment was migrating into the other thing. So we had the spray shield there. We had a really unique nozzle. It was a misting nozzle that you would actually typically see more in a garden, used for a garden area for maybe watering potted plants or things, hanging baskets and things where you don't want a large droplet size. So that is something for the readers and for the listeners today, but anybody that goes and reads this paper, that's kind of one of the unique, I wouldn't call it a limitation, but it's something that you have to think about when we're putting this into practice in real life is you sometimes can't control the droplet size or even the irrigation uniformity. You can improve those things, you can adjust those things, but it's likely not going to be exactly like it was in this research setting where we had I think a 1 gallon per minute misting nozzle. It wasn't so fine to where it wasn't getting into the soil, but we were able to really dictate the flow, and so that we weren't moving seeds everywhere in that situation. And we also had very uniform coverage. Whereas, okay, yeah, you come and you read this paper, maybe you read somebody else's paper on irrigation and ET and things like that. But you've also got to think about, is my irrigation system, is my sprinkler system up to par in terms of the distribution uniformity, in terms of my precip rates and things like that. So, even though you're maybe following ET guidelines, that doesn't mean your irrigation system is applying that water uniformity. So things to think about when you think about reading this paper is we probably had upwards of 90% irrigation uniformity, on all of these treatments, no matter if it was 125 or 50% ET. So we knew how much time it took to apply, whatever the inch amount was, or if it was 2/10 of an inch of water that was lost the previous day, then we knew how long it took to apply that 2/10 of an inch. We had a little graduated picture and did the math and scaled it down to size. And that's what the stopwatch for is. We knew when to turn on and turn off the water there with the hose.
Yeah. I want to point out this little inconspicuous table here just because I think it speaks volumes in a very simple way. Cumulative amount of water applied in inches over the 28 days of grow in 2016, 2017. I'm just going to round it to 3. Okay, both of them. 3 inches over a month for an establishment from seed. So that's less than an inch a week, probably like 0.8 inches a week, whatever it is. And you can see the amount per day, the ET per day. It's not much, guys and gals. For 3 inches for the month to grow it in. And if you have an irrigation system and you just turn it on and you go, I'm going to turn it on for 30 minutes and 20 minutes, you're probably applying and you're doing that every day, or God forbid, 2 or 3 or 4 times a day during establishment, you're probably 10xing this in terms of amount of water applied. In other words, this really drives home the magnitude. I mean, I know you didn't do this. Isn't a data separation. You're just showing how much you applied, but it's not that much. 3 inches for the month. So it doesn't take that much just to kind of keep the seeds moist. And in this particular study, the total was 3 inches for an entire month. So keep that in mind. If you go, well, heck, it's going to take me a month to grow this in. Unless you live in like Southwest Texas or North Dakota somewhere where the ET is like 0.2 inches a day or whatever. I mean, it's incredibly high. It's not that much water, guys and gals. Keep that in mind. Sorry, I just like that. Okay. Well, you did some modeling, and in the sake of, I'd like to have some time to answer some questions that are in the chat, Dan. So
just real quick, Travis, is one more thing that we didn't get to is that we also did use covers, which I know some people aren't able to do or maybe haven't had time to do. And that's a recommended BMP that I think is often overlooked when doing establishment from seed. If you do have the time and the resources or the labor to put out covers, it really improves. And just from an anecdotal viewpoint, is like a lot of the things that we did out at Arkansas, bare soil, seeded establishments for a lot of different trials. Just seeing the impact of covers was pretty big. So that's just another caveat to think about as we discuss these results. is that we did utilize a straw mulch the first year, the tall fescue, because again, this is kind of a last minute thing, and that's what we had on hand. But all the other ones, we used some germination cloths. So just something
Yeah.
to keep an eye on. So.
Just for the audience listening, I'll get to your questions, guys, at the end. I'll be sure to put them in the chat, and Dan and I will go over the questions. But but very good point, Dan, is that if you want to make it rain in Lexington, Kentucky, put out an NTEP trial. It will rain like you wouldn't believe. And these blankets, oftentimes we would use as well, because they greatly reduce this flow of water over the surface and getting the seeds to keeping them where they are. So I'm not a huge use blankets for every situation sort of guy, but if it's going to rain, that blanket will pay for itself many times over. There's no question. So when I mean blanket, I don't mean a blanket at your house. I mean a germination blanket like Dan has listed here. So, okay. So
yeah, they definitely help reduce the raindrop impact, the rainfall impact, but I think even more so, they also help just keep things more uniform across the surface in terms of temperature and things like that.
I think you're dead on. Yeah, for sure. I mean, there's value to it. I just don't want to drag those things out and drag them back in. So I'm like, And then every time I wouldn't do it, Dr. Munshaw would do it, and his seeds looked perfectly fine, and mine were just like because I tried to shortcut it and not do it, and those blankets will pay for themselves for sure. Okay. The irrigation effects on tall fescue. So basically, you had a lot of modeling, and I'm just going to cut to the results. But you're basically modeling it to 80% turfgrass coverage, and at what point it reaches 80% turfgrass coverage, you sort of call it, done. And what you'll find here on these graphs here, guys, we're going to skip to figure 3 here. And if you see graphs like this, you can guarantee you it was a computer predicted model, and that's what they have here. And on this figure here, we have 2 panels. The top panel is 2016, the bottom panel is 2017. On the x-axis is days after seeding, and then turf coverage percentage on the y-axis. And just this is what I mean. I haven't had a chance to show this to my audience yet, Dan, so I'm glad you have it here. When I mentioned the turfgrass grows in a sigmoidal way, this is what I mean. It grows slowly, and then it takes off, and then it levels off towards the end of the establishment period. And that's what you see here in Dan's work. For these different models. But do you want to kind of just walk through and show us these models and the various reference ET? These lines are the reference ET or irrigation treatments.
Yeah, absolutely. So as Travis mentioned, on the y-axis, you have your turfgrass coverage. And for this particular model, these data here are actually presenting, you could estimate the days 80, but these data are showing the days 50 in the second column on both the top table and the bottom table.
Okay.
And just looking at, how much coverage and how long does it take to get halfway there in terms of covering the plot, covering the area there and there. You can certainly drag it out. You can, if you had like a ruler or just a pen and pencil, you can print this out. I think most of these, except for the 50% ET replacement, got up to 80%. Turf coverage there, according to the x-axis there, the bottom axis with the days after seeding. So,
I see.
So the way you interpret this is you can either look at the data that's there in the table in the column, you could very easily just make a right angle, draw over on the y-axis. Well, I'm interested. How many days did it take to get to 50% or 60%? You could draw a horizontal line across from 60 until you run into the red line, which is 125, the green line, which is 100%. The blue line, which is 75%, or the black line, which is 50%. The one thing I do want to point out, and the audience may remember, we talked about using 2 different cultivars of tall fescue, and same thing in the bermudagrass trial. We didn't really see an effect in differences with whether this was already known to be drought resistant versus a standard. So these data are pooled. These represent data, the results, the findings for both the RK4, the TWCA, the drought-resistant variety, or the cultivar, and then the Rebel Exita, which was just a standard. There's a lot of Rebels varieties of the tall fescue world that are out there. So that's important to kind of point out or to think about, is that while you may see some drought resistance among varieties or cultivars at maturity, we didn't really see that in either of the trials with bermudagrass or tall fescue during the 28-day establishment period. So as you can see, though, with these data here, 2016, 2017, with the higher ET rate replacements, 75, 100, 125, all
Mm-hmm.
pretty similar, in
Yeah.
terms of reaching 50% ETE coverage. You're
Yeah.
looking at anything from 22.2 to 24.1 days, all within about 2 days of each other. And I know Travis has done a good job, and I always appreciate when Travis or other scientists I hear, there's a lot of things we do in research that maybe are statistically different or statistically significant, I should say, but visually, can you see that as a end user, or as a consumer? You know, you're talking about 2 days time here. You know, well, maybe the 75%, well, it was only at 40% coverage at 22 days, but then by day 24, it was right up there at. So, again, while statistically these are significant, differences, and we have some variation, visually from the end user standpoint, you know, they may think on day 22 that the 75% ET replacement was at 50% coverage too. So
Yeah.
the
Yeah.
only other difference I'll point out with this is that on the 2017, we see it reached across all the treatments, it seemed to reach 50% 50% cover a lot sooner. And we kind of believe that was attributed to two factors. One was that we started earlier because we
Mm.
kind of knew what we were doing then. We'd already done one rep of the trial. It wasn't like a last minute project. I think this one started, the 2016 started in October, and the 2017 one started in September. So we have a little bit still
Oh, yeah.
warmer soil temperatures. We
Yeah.
also switched from using straw, because again, in 2016, last minute study, that was the only thing we had on hand, to 2017, we had germination blanket, which again, while
Mm.
straw is a cover, it does not provide a more uniform or as uniform a cover as the germination blanket. Right? So
Mm.
uh, those are just some of the rationale we think of why we see that increase, almost a week
Yeah.
sooner to reach, 50% cover in 2017 across those three treatments. So, and even 10 days sooner in the 50%.
Sure.
Um, so,
Yeah.
but
Yeah. That earlier seeding in 2017
mhm.
could have a major impact for sure. I mean, you're gaining a week of establishment by doing it a little bit earlier.
Mhm.
So not just you're gaining a week because you did it earlier, but it's growing in a week faster is what you're saying, because it's warmer temperatures. Okay. Well, let's go to figure 4, and this is the confidence intervals. This was the first time I've seen a graph or a figure sort of like this. I do like it. On the x-axis, we have days after seeding, and then you have 2016 as the etched boxes, and 2017 as the completely filled boxes. And the colors are all, relative to the ET that you applied water. Do you want to kind of explain the importance of this figure and how people can use it?
Yeah, absolutely. So this is actually kind of a Dr. Karcher staple, if you will. I don't know how many other researchers are using it, but he's a whiz at using some of these data visualizations, and especially with some of these confidence intervals and these results. But basically, on the x-axis, you have days after seeding, and then the length of the bar, that kind of the width of each of the bars that represent the different irrigation replacements and the different years, kind of like plays a role in the sense of if these bars are overlapping. For instance, the bottom square there, 23.2,
Mm-hmm. Mm-hmm.
we see, okay, well, that's the soonest, that's the earliest there in 2017. So again, warmer temperatures, earlier seeding date. So it reached 80% cover a little bit faster than any of the 2016 data did.
Okay.
But as a result of that, though, so we have those confidence intervals for that treatment, for the 100% ET treatment in 2017, that green solid bar, 23.2. The other two boxes immediately above it, though, 24.6 for 75% ET, and 25% or 25.0 for the
Mm-hmm.
125% ET replacement for 2017, while those are almost a day longer, respect each of them. So 75% was almost a day longer, and 125% was almost 2 days longer to reach 80% coverage. Statistically, they're similar
Yeah.
because the bars overlap.
Okay.
So you can see that if you were to like draw the line through one length or one side of the 23.2 box to the other box, you can
Mm-hmm.
see that portions of the 24.6 box,
Yeah.
25.0 box also fall
Yeah.
within that. So
Sure.
Dr. Karcher's got, and other, I'm sure other researchers do. I've seen this done a lot more so with variety trials, Travis,
Okay.
and looking at, they'll have the names of different cultivars of varieties instead of the, whatever a numerical value, and they indicate. You see this a lot in drought research, looking at dry downs, like, well, how long do they retain their green coverage, and so they'll have those confidence intervals represented, those data represented in this way. So it's kind of neat because then you can kind of see, you can just follow the overlapping bars. It's not too much different than like what you may have shown the audience before with, you know, means with the same letters, or
Yeah.
means with,
Sure.
those types of things. So
Okay.
it's just another way to present the data. You can see, let's stick in 2017 there, the yellow bar 31.2. And I should say, we aren't trying to, and I don't know if I remember to put a statement in here, but these are strictly looking at within year. We're not
Mm.
trying to, or deliberately trying to compare 2017 to 2016.
Yeah. Okay.
They're
Sure.
just both here in the same figure.
Yeah.
But within the year, that's why we have solid color versus the etched lines, as Travis mentioned earlier. All three of those treatments, the 125, 100, 75%, none of those bars fall underneath, or crossover on the 50% ET line. So that
Mm-hmm.
one was obviously statistically, took significantly longer
Yeah.
statistically to reach 80% turf cover, as predicted by the model there. So
Yeah. So it wasn't
same
enough
thing.
water. 50% ET is definitely not enough water in this particular
Well, I
case.
mean, at 80% coverage in a month, though. I mean,
Well, you still got it. Well, that gets a good point, because I brought that up before on my channel as well, Dan, is that, yes, it took longer, but it did grow in. Eventually it grew in. And some other, I can't remember the other paper I went over that had the very similar results, is that, yes, okay, it took longer. But in my case as a homeowner, I don't really care if it takes 4 weeks or if it takes 6 weeks or 7 weeks. I just want it grown in before the first frost, right? So in my case, I don't care. Someone who does care, though, okay, well then, you need to err more on the side of a little bit more water. But in my case, a homeowner that doesn't really care about my lawn that much, I'm just like, it will grow in, even with, 50, Dan, I don't know how to express it in a way that makes sense to the average person. 50% ET is just, it's hard to measure that low, that amount of water that low, and put it out over the turf uniformly. It is very, very little water. So we're talking about just touching the seeds with a little bit of moisture and doing that regularly is enough to get it grown in, even at 50%. So I'm glad you correct me on that, Dan, because that is, you're right about that. It got grown in. So I misspoke.
Those data for 2016 are similar. Again, colder temperatures, use of the straw as opposed to the germination cloth.
Yeah.
Or
It still got grown in.
It still grew in within about those other three treatments. Within about 5 days of each other. Just
Sure.
Right at a month, or right just a day or two over a month.
Yeah.
50% ET. It took 6 weeks, or 6.5 weeks.
Yeah.
To grow and to reach 80% coverage.
Sure.
Basically, what does that look like to us? If you walked out and you had just established a lawn, and 80% coverage from a research standpoint, it may look like 100% coverage to many of us just from the naked eye. So.
Sure. Yeah. I have to have a keen eye to separate that out. Well, these are some of the statistical parameters. Let's look at the last little. Well, here's the other graph. Now, this is bermudagrass. And we see, give or take, very similar results in bermudagrass in this model. It's a turfgrass, the same exact sigmoidal curve. It's the same exact everything. It's just we switched from tall fescue to Bermuda. With a little exception in 2019 where 75% ET it was more similar to the 50% ET. The point being is that on both cases, the 100% and the 125 consistently grew it in quick as the fastest, with 100 being equal to 125. So why apply 125? I mean, that'd be my question. Why do we need to apply 125 if 100 is doing the same job, right? Because we're applying less water with 100. But You could grow it in with 50. It's just if you're willing to have patience and you just want it to grow in at some point and you're not particularly in a race, it'll grow in with 50. Turfgrass is an amazing organism. I've mentioned that I don't know how many times on this channel, Dan. It is hard to kill Bermuda grass. If anybody can figure out these two things, we can all patent it and retire. How to grow Bermuda grass in the shade and how to kill it, period. I mean, it's not easy. It's not easy. And so in this case, this is an exact example. It's like it even grew in. I mean, look at this, Dan. 2019, well, let's look at 2017. You grew it into 80% in 25 days with 50% ET. That's ridiculous. That is Bermuda grass. It is the world's worst weed, and we grow it as a turf grass.
Yep.
It's hard to kill.
The only caveat I would give with this data is that we seeded, I think in 2017, they seeded it in July. I don't remember when Tyler did it in 2018.
Oh, okay. That could be very different.
In reality, I think they were kind of outside the recommended window for seeding Bermuda grass. They're a little bit past the window.
Yeah.
Let's see if I find it here real quick.
Well, while you're looking at it, the window, if you're seeding Bermuda grass, the window is like right now. If you're in the transition zone in Tennessee, Kentucky, Arkansas, you don't want to wait till the end of August to get that stuff out.
So Tyler did it in August 6th. I did it in July 19th.
There you go.
And I don't remember why. I know in Tyler's case, and some of you may be wondering why was there 2 years between the Bermuda grass applications. If you're an Arkansas fan and you pay attention to the weather or anything, we actually had a big old storm come through, and Travis might remember it because like the whole turf science world heard about this. But we had a whole bunch of storms come through Fayetteville, and it wrecked a bunch of our rainout shelters and wrecked a lot of the research facility as a whole.
Oh my gosh.
So 2018 was kind of a crazy year they had to cancel the field day. They had to cancel a whole bunch of stuff. So it got postponed, and then you have to order a brand new rainout shelter and all the insurance and all those things. So I appreciate Tyler doing that. But again, it was kind of probably also aided a little bit by the later temperatures. Mine was mid-July. Tyler was early August. But again, if you were to do this at the optimal time, if you were the recommended time, late spring, early summer for seeding Bermuda grass, I don't know how likely the results would have been, but as Travis mentioned before, man, Bermuda grass is pretty resilient. It kind of knows what to do. So
yeah, it's hard to kill. It really is the world's worst weed. In agriculture, they try to get rid of it. You just can't get rid of it. But in our world, we maintain it and it looks great. So if you're interested in looking at like the days to 50 of these different cultivars, it's here. Basically it's 23, 24 days on the tall fescue. You also have it down here in Bermuda. I kind of skipped through that, but it's Bermuda grass is like 12 days. That's fast. Days to 50%. Princess 77, which I'm not a huge fan of, but I know people like it. Sahara 2. And then, the average was 12. So it's quick. That's quick to get that grown in. Let's look here. So here's the tables. We're kind of summing it up here at the end. The number of days to reach 80% turfgrass coverage. And then you have the irrigation 125, 100, 75, and 50. And you have tall fescue and Bermuda grass. This sort of kind of nicely sums it up in one table, not just the days, but also the amount of water you applied. And you can see that for the most part, give or take, and correct me where I'm wrong, Dan, but correct me where for the most part, in a pragmatic sense, once you get to 75% ET, if you get below that, you're going to see some prolonged status. It's going to take a little longer to grow in. You're looking at tall fescue from 30 days of 75% ET to 40 days, essentially, when you drop it down below that. But when you go above that, you're gaining 1 or 2 days. So you're looking at 29 days at 75% ET, 27 and 27 at 100 and 225. So to me, it kind of seems like these kind of group together once you get above 75. And the same thing goes with Bermuda grass. The 17 days, 18 days are all grouped together when it's above 75, but when it drops below 75 is when you see this extra length, coming in towards the end. So, and then next to it is what I like this table is next to it, you have the amount of water you applied. 2 inches over a month, or a little more than a month and a half on to 50%, and it still grew in. I mean, I think if we could have like a field day, like a participation field day in turfgrass, and have people go out and actually try to apply that little amount of water, I think they would have a greater appreciation of what we're talking about here. It is not much. It is very, very little. Even the high 125% ET is not that much water. And when you're putting it out over a month and a half or 30 days, whatever you did, it's not that much water, but I don't know if people really can appreciate it unless they're out there doing it. Because you turn it on, and you're like, whoop, stop. I'm like, what? I just turned it on. Yeah, you just turned it on. And now you got to stop because you're going to do that again tomorrow or again the next day, and it's going to be cumulative. So I do appreciate you putting these tables together. Oftentimes we kind of, as authors, we kind of get this kickback from reviewers and editors because it's a little too simple, but it summarizes things nicely. Somebody like a homeowner, Dan, or a lawn care operator can look at this and go, oh, 2 inches? That's not that much.
Yeah.
3 inches at the max, 3.5 inches at the max. That's not that much water. So let's just go with.
That's not even to mention that maybe in a real world scenario, like a non-research example, they would also be getting rainfall. Hopefully,
exactly. Yeah, rainfall.
This is literally all. Yeah, there was no rainfall at all.
Yeah, this was under a rainout shelter. Exactly. Yeah, don't forget that, guys and gals. Well, you sum it up nicely, and at the end you say, within our 2 studies, establishment rates were similar with irrigation replacing equal to or 100% 100% ET, suggesting that daily irrigation replacing 100% ET during the first 28 days after seeding is favorable for tall fescue and bermudagrass. So that sums it up. And as we mentioned more than once here tonight, yes, 100% is suggested. You can do it with less. If you can definitely do it with less. Just expect another day or two, or maybe a week to get it established at 50 or 80%. But it'll get there. As long as you're giving it a little bit of water, it's not going to freeze on you. You'll be fine. Well, Dan, I appreciate it. Was there anything else you wanted to cover before we go into the questions?
I just wanted to point out, and so this might be a question that people have, but we talk a lot about ET here, and we're trying to make these, at least for me personally, I try to make my research meaningful for the practitioner, for the homeowner. And so, okay, maybe they have an irrigation system, maybe they have all these things, they know how to see, they can use covers, but the ET thing is what trips a lot of people up. It's crazy though now, like it's crazy now though that when this research started versus where we are now, is that now there's more ET data available, whether it's Inman Monteith model, the reference ET, or whether it's a Hargraves model, which is more basic, but still a really good estimate. And I know Mateo was on here a few weeks ago, and he talked a little bit about it. But even the irrigation companies are now producing smart controllers that can predict ET or connect with local weather stations, or they'll use historical data. You put in your zip code, and while it may not be today's ET, it's going to be pretty close based upon a 30-year data set for your location and time of year. Because if you think about your irrigation controller, well, you have to put in the date, you have to put in the time of the time of day. With a smart controller, you're just putting in the zip code along with those other basic factors that you would already be putting in. So, in Kentucky, I think you guys have I don't know, I shouldn't speak to that, but when I was there, they probably still have the MesoNet. Some states, I know Oklahoma has the same thing. Some states have a statewide MesoNet that provide the ET estimate for your county. Now, you might want to look at the surrounding counties depending on where you are in your county, but there's ET data available now, much more so than when this research was first done, and even 12 years ago when I first started the PhD. So that's something that I encourage the audience to think about. Is now we have a benchmark, 100% ET, and now there's resources available to get that ET data.
Yeah, and I haven't used any of those irrigation controllers that actually connect to the outside stations for the ET data. I've used the old ones that have the little plungers inside, and they actually measure, and they fail, and you got to replace them, and they didn't really ever work. I ended up using more water than I would have without it because you got to change those things. But the ones that they're connecting outside, and you go, well, the ET station's in an hour away, or it's whatever. Granted, it's not going to be that exact compared to your location, but it's probably going to be much more accurate than you just out there turning it on for 15 minutes and letting it run every other day or whatever. It's going to be far, far more precise and more in line with what the turfgrass actually needs and limiting what it doesn't need. Okay. This sort of kind of goes into this question, Dan. Ashani says, this may be a lack of understanding, but why don't sprinkler controllers allow watering by inches instead of minutes like Celsius or Fahrenheit on the thermostat? I don't really know how to answer that. But that kind of goes with well, you want to answer that, Dan? I don't know how to answer that
I'll
question.
give it a stab. That's a great question. I think one of the things is, from a universal standpoint, whether it's inches or millimeters, I think most of them are just built upon a timer, and so you're
Mm-hmm.
programming runtimes and scheduling. I think it's a little bit easier from the manufacturing standpoint that way, because
Yeah.
then depending on your different zones,
Sure.
think about from a residential complex or even a commercial complex, like you have things that aren't turf, that
Yeah.
like landscape beds and flower
Yeah.
beds and garden areas and other areas that may be still connected to that same controller. So it's really maybe more intuitive for somebody to just time, they know how long it takes to apply an inch, in one zone um, of their lawn or their landscape or their
Yeah.
property and stuff. And maybe they can scale back the irrigation based upon a time increment.
Yeah.
And that is a good question with respect to the fact that we talked about earlier with just kind of just turning it on and off. A lot of this also goes back to your irrigation system uniformity, whether
Yeah.
it's spray heads, rotors, small multi-stream rotors. It does play an impact. It does play an
Sure.
impact in terms of getting that small amount of water out that Travis mentioned earlier. So,
Yeah. Well,
um,
even the ET systems, you still have to do an irrigation audit. You still have to know how
yep.
much water is being put out in your system, even if it's 40% uniform, whatever. You still have to know and get a ballpark as how much water is being put out per minute or per 20 minutes or however you want to do your audit. And I don't know those controllers at all, Dan. I don't know if you then tell the controller, hey, my system is putting out, 0.2 inches of water every 20 minutes, or I don't know how those work. I've never
so
used those, but
some of some of them, but these are kind of more outside the realm of most consumer affordability, I would say.
okay.
So most of your standard or even smart residential irrigation controllers, or even like light commercial, um, they're just going to have the regular dial, the regular dial or clock based system.
Hmm.
There are some controllers out there, um, more so on the professional side, but even in ag, I think, and even in some engineering practices where you can put in some inputs of your nozzles and your sprays. And if you know like your pressure, if you know your nozzle specs that would be delivering inches per hour,
Hmm.
then you in some
Okay.
of those systems, I don't know the brands off the top of my head, but I've seen these, is that
Okay.
it can then like what is your target inches that you like to put out?
Okay.
And then if it already knows those other specs of your system, like, well, I have this, whatever nozzle on my rotors, or I have this many rotors in my zone, and this is my operating pressure and all those things.
Mm-hmm.
It can kind of estimate, how long to set up the system for
Okay.
to apply that 2/10 of an inch, half an inch, whatever it
Yeah.
is. The likelihood of most irrigation controllers, even smart controllers that homeowners going to have, like from Rainbird, from Hunter, from Toro, or all these other companies that are out there, they're not going to have all those inputs for you to get down to your nozzle specs, your operating specs, and things like that. That's more
Yeah.
so on the professional side, and
Okay.
even in that situation, I don't know many that are using those types of systems.
Yeah. Yeah. Here's a question that I'm definitely going to ask from a member, Paul. And I'm Paul. Sorry, Paul. I don't know how to pronounce your last name. I don't want to even give it a shot because I might offend somebody. I don't mean to. Paul, he says, does applying a moisture retention spray or hydrogel based product after seeding help to retain moisture? I have my answer to that, but if you want to answer that, Dan, feel free.
Yeah, no, I honestly don't know, Paul. I haven't seen really any evidence or looked into that at all.
Mm.
But that would be interesting to evaluate if somebody wants to provide some funding for that.
Nice little plug.
Moisture retention sprays, hydrogel based products.
Yeah.
Yeah, I don't know. I think it would be maybe challenging on
Yeah.
if I don't know when. I'm not familiar with this in terms of when is that applied, but
Yeah.
I think it'd be kind of hard to apply that formally walking across seedling area. So, but
Yeah.
Travis, I'll probably share a little bit of whatever your answer is too, because
No, I
I honestly
mean,
really don't know.
there was some work done on that. Again, I don't know the water literature that well, but I know there was some work done on that. I'm not pulling it up in my head at the moment. But I would just say that, You know who we should call? We should call Burned. Has Lenauer ever done anything like that? I mean, him or Dr. Bayard would know over it, and UC Davis.
They've done a lot.
That's who would know the questions that answer the answer to that question. I would just say in general, like hydromulching or something like that. When you're sticking something, when you have something in the system that's sticking the seed to the soil and keeping it from washing off, it's probably going to be beneficial if the conditions arise that would have washed the seed off. Or if suddenly your irrigation main line breaks, and the soil's suddenly getting dried out. Well, if you put something on there that would have held the moisture in, like a hydroseeding or a mulching or whatever the case is, it could be beneficial. I don't know the literature, so I can't really say on that particular topic. I know on established turf, those products have limited value when the turf is already established. You're not going to greatly reduce or even meaningfully reduce any sort of water applied, typically by applying like a humectant or a hydrogel type of product on established turf. But I can't speak for growing in. Let's see. I don't know if this is a question. Let's see. Joe Callis says, I love that there are specific item numbers and descriptions for all the items used. I haven't noticed that on the papers we've gone over. Okay. I guess that was just a statement. No problem. Let's see if there's any other questions before. Let's see. Yeah, I got, let's see. Oh, Jonathan Ralston, thank you, says, don't forget to hit the like and subscribe button. I always forget to do that. Oh, here you go. He's patting you on the back, says, thanks for the great guest. That comes from Jonathan Ralston. Yeah, Dan, I feel bad. We haven't really had a chance to sit down and talk before tonight. I mean, it's one of those things when you're at science meetings, you just kind of cross people and you hear people and you're like, oh, he's at Arkansas. Yeah, he's at Virginia Tech. And then, you're doing your thing. It's kind of like keeping up with you. But I just never really actually ever sat down and said hello and had a conversation with you. That's a lot. I think I'm guilty of that and a lot of people. So we resolved that tonight.
I appreciate it, Travis.
Damon Daniel said, would you expect similar results for sprigs or sod in terms of irrigation needs?
Damon's one of my former students in our certificate program. He's one of our great turf managers here in the Mid-Atlantic region. Damon, that's a great question. I would love to do some research on this, but time and funding and other commitments, that I think that's kind of the next way to go. Right now, I would say, kind of thinking about where this started was, we're up the turfgrass, community was heavily scrutinized. It still is, but lots of water being wasted, lots of efforts towards water conservation. Most people were seeding, so we just went with seed then. There's probably, at least on the residential side, especially from homeowners who are doing their own irrigation, probably doing seed, probably not a lot of homeowners installing their own sod. Or if they are, most of the time the sod's installed, the contractor runs the irrigation system, and all that stuff's been running longer than 28 days before a homeowner even moves in. So, but that to answer your question, that should be done. That's something that could be done. Especially, we don't know what's ahead. The end of this year, 2 years from now, 5 years from now. It never really came to having water restrictions yet that I'm aware of. As we mentioned earlier, like most of those water restrictions, day of week or time of day, they didn't apply to seeded establishment. So that's kind of what we were looking at there. It's like there might come a day where even during that first month of establishment, there's irrigation restrictions. So same thing for sod and for sprigs is, can we dial in at least a benchmark, right? Is 100% ET also suitable or adequate for establishing sod, establishing sprigs? Great
I don't know that. Yeah, I don't know the answer to that question. Again, I'm not a water person. I can answer that question with regards to nutrient movement offsite. We've done a lot of work with leaching, but with the exact amount of water you need to grow it in, I'm not sure. Next question from Lewis Carter says, does a root stimulant like Agri-Rouse help with grow-in? I don't know Agri-Rouse.
I'm not familiar with that. I apologize about that.
Yeah. I mean, the only thing I ever use root stimulants for are to like a root hormone if I'm doing like cuttings on ornamental plants around my house or garden. I'll take some cuttings and I'll dip them in some root hormone to help encourage some root growth. And they can help in that regard. But in regards in turfgrass, I'll say I don't know, but the chance is if you have a normal nutritional program, the chances that adding a root stimulant would benefit establishment or growth is probably pretty low. But again, I don't know. I don't know root stimulant work and grow in, but my guess is if you have adequate nutrition, it's probably limited. Its value is probably limited, I would think. That's my opinion.
Also the small amount of root mass, root density there, especially in our study the first month, may not be worth it even to put out something like that.
There was a question too in here, but now my mouse is screwing up on my end. It says, there was a question in here. My computer's wigging out on me. I'm sorry, guys. I'm probably gonna have to shut it down. But the one question was about, let me see if it fixed it. Okay. Where was it? It says, Fusik, whatever that means, says, can I mention a quick comment about subscribing? An iPhone and iPad, I tried a few times. Yeah, I have the biggest problem getting people to subscribe and join on the iPhone. I get more emails on that probably than anything. My own wife couldn't figure out how to do it, and I'm sitting right next to her on her phone. So if you on the computers, it's very easy to subscribe and become a member, because I don't know why, it's just the buttons are right there. But on the iPhone and the iPad, for some reason, it's difficult sometimes to find the join button or to find the subscribe button. But you can always go to like YouTube's / Turfgrass Epistemology and then put like @join. And I think you can actually see it in the description of each video. I think I have that in there. Click that and you can subscribe and join. But I do know that's a problem. It's out of my control. It's YouTube for some reason makes it difficult on the iPhone to see that. And the last question from Chuck Benzing. Is there any land grant BMP that either of you are aware of that address pre-germination methods or procedures? Same question, Cooper Jack. So I think what he's getting at here is like pre-soaking your seeds or imbibing the seed with water before spreading it out. I can tell you this, I know absolutely jack squat about that topic. Nothing. So do you know anything, Dan? I don't know anything about it.
I don't have experience. I know what you're talking about, and I agree, Travis. I feel like he's maybe alluding to the pre-germinating seeds and the 5-gallon bucket and things. Where I would recommend, I can't speak from the land grant side of things, but another group I would refer you to, though, or authority, I guess I should say, or group of people, is sports field managers. Many sports field managers, especially those that do overseeding, that need to get the field ready for play for the next game. A lot of them have, whether it's the SFMA or even just some of these sports field managers that have their own websites or Twitter profiles or social media channels. Some of those guys, they may even have like a TikTok or some other social media thing that walks you through it.
Okay.
I've seen it in those situations, but I can't speak off the top of my head from a land grant perspective and pre-germinating seeds.
Yeah, Chuck, if you're looking for data on it, I don't know. I can go look in the literature and see if I can find something, but honestly, I don't know any. I've never seen any data on it, but I've also never looked for it, so I don't know. Well, Dan, we've said it all tonight. I really appreciate your taking the time. By the way, look at Dr. Sandor. He's still in his office at 10:30 at night in Virginia on a Tuesday night. That's dedication. So I really appreciate your time. I learned a lot. I really appreciate you publishing this work as well. And thank you to Tyler for finishing up that last year there on the bermudagrass work. I really appreciate that. Anything else before we sign off?
No, I appreciate you having me, Travis. I would just say for the group, with irrigation, and I think Travis has talked about this at length as well with some of the other topics and guests that he's had on, but a lot of this is more about behavior change. The grass knows what to do, whether it's fertility, whether it's irrigation, some of the other things, but a lot of this is changing behaviors, like we talked about tonight, with cutting back the water, just using 100% ET as a benchmark, but trying to get whether it's you yourself or whether it's the people that you work with or the other person, the DIY homeowner that is trying to learn from you. A lot of it's just trying to get them to change their behaviors, and once they can do that, then the education starts to really take effect. So.
Yeah, we got to figure out something. A lot of people just don't even know that you and I exist. A lot of people don't know turfgrass programs exist. Land grant institutions, a lot of people just don't know that. And so I guess in some small way, I think this channel helps maybe get that message out a little bit more that there are people who spend their entire professional career studying turfgrass, believe it or not. And you and I are two of them. So appreciate it, Dan. Hang tight. I'm going to shut the show down and I'll come back to you and say goodnight. For the rest of you, I'll be back in a few weeks. I'm going to be traveling. I'll be gone for a few weeks. This actual show on YouTube won't actually be even on a podcast for at least 2 weeks, because as soon as I hang up with him, a couple hours, I'm driving straight to the airport. So it'll take me a while to get it on a podcast. Thanks so much again, Dr. Sandor. I really appreciate your time. Thanks for everybody else. I'll see you all in a few weeks. Thanks. Bye.